All right, so in section 6.3, we're going to be multiplying radicals. And when you multiply radicals, you multiply them in a specific way. So I just want to really quick show you what it's supposed to look like. So if I were to put like 2 square root of x times negative 6 square root of, let's say, 4x. I mean, I'll do a 4x, because then that means I got to simplify it at first. I'll put a 3x right there. All right, so they want you to multiply that. Then what you're supposed to do is you multiply the outsides only and the insides only. So like the outsides multiply together, the insides multiply together. You never multiply like the 2 times the 3x. Don't do that. Okay, the 3x is inside the radical. The 2 is outside. So if it's outside, you're going to multiply it with anything outside. Okay? And whatever's on the inside will multiply with whatever's on the inside. Whether or not they're like terms, it doesn't matter. That's the beauty of multiplication. It's not picky. It's not like addition and subtraction where it's like, oh, this is an x squared, this is an x squared, I can put them together, right? Multiplication says, I don't care. If it's an x and an x cubed, we'll put it together, it becomes x to the 4th. Okay? So multiplication is not picky at all. It just says multiply it. Go ahead. We'll fix it up. So outside numbers multiply with outside numbers. The inside numbers multiply with the inside numbers. So when I do this problem, I end up getting 2 times negative 6 is negative 12. Square root of x times 3x is 3x squared, right? Now, normally I'd be like, I'm done, but pay attention to the inside of the radical, okay? Notice how I have an x squared there? And isn't the index to this problem a 2, right? That means that my index matches my power, which means that I get to bring this x outside. So, my final answer would be negative 12x square root of 3. Okay? Multiplication of this thing is not hard. Multiplying is super easy. The hard part is making sure you simplify things properly at the end. That's going to be the hard part for this section. Multiplying is simple. I think it's actually easier than addition, because with addition, you have so many little rules, right? They have to be like radicals, and you add and subtract them. Like, we got to make sure that you can add them together. Multiplication is not picky. It says multiply me with anything. X times y, 2 times y, 2 times e. I don't care. Just multiplying. Okay? So that's why it's so much easier. But the harder part is cleaning up the mess after. Okay? So it's always a little bit of a give and go here for that. So let me show you guys some examples from your homework. So remember, when we're doing this stuff, you are going to just multiply these things out. Outside numbers times outside numbers, and then the inside numbers with the inside numbers. Okay, the stuff inside the radicals. So all this is going to be simplified, okay? I may just do a bunch of A, B, C, D, E, F, and we'll just call it example 1. So here's part A. So radical 10 times negative 3 radical 5. Remember, outside numbers times outside numbers, inside numbers times inside numbers. Now, if you can reduce before you do anything, if you like, let's say it was like a square root of 9 instead of a square root of 10, then make it a 3. Write 3. That makes it easier. Okay? But square root of 10, I can't break that down, because 10 is 2 times 5. Right? And square root of 5 is just square root of 5. I can't do anything with that. So these are as simple as they can be right now. So I'm going to go ahead and start multiplying. In the front, there is a 1 right here, right? There's a 1 there. So 1 times negative 3, that's negative 3. And then square root of 10 times 5, that's 50. So we're done multiplying, but now we got to fix it, right? If it's possible. Well, give me 2 numbers that multiply to 50, one of which has a nice square root. What do you guys think? 25 and 2. Yeah, 25 and 2. And what's the square root of 25? 5. So the 5 is going to go outside. I'm going to skip the in-between step. Okay? So the 5 goes out. Negative 3 times 5 is negative 15, radical 2. And I'm done. Notice the multiplication was easy, right? But the fixing part is going to make you think a little bit more. Multiplication to me has always been like mindless. Like multiplication doesn't think about what it's going to do. It just says do it, right? Whereas addition and subtraction always has little rules, right? Like it has to look like this, it has to look like that. Whereas multiplication says I don't care, right? But we do have to fix stuff after we multiply. So that's one of the problems from your homework. All right. Let me give you another one. I'll put this one right here. 2 radical 3. So you're going to notice they are going to start changing the way the problems look, but it doesn't matter. It's still multiplication. In this case, we're going to have to distribute. And like I told you guys in the last example, look at all the radicals and ask yourself, can I simplify them first? I got a radical 3, can't do it. Radical 10, can't do it. Radical 3, can't do it. So, in other words, I'm stuck here, so let's go ahead and multiply. All right? So I am going to distribute. Remember, we have to distribute. Let me change the color here. We are going to distribute here and here, here and there. Okay? Now remember, outside numbers with outside numbers, inside with inside. So let's do 2 radical 3 times 10. So 2 radical 3 times 10. Radical 10, sorry. So 2 times 1 in front of the radical 10, that's 2. Radical 3 times radical 10, that's 30. Okay? Minus, whoops, sorry about that. I pressed something incorrectly. Minus 2 times 5, that's 10. Square root of 3 times 3, which is 9. All right, is there a way for me to break down 30 so that it has a nice radical? So let's see. The factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. None of those have anything, right? So radical 30 is done. That's it. What about radical 9? Yeah, what does that become? 3. So this can be simplified. This will become 2 radical 30 minus 10 times 3 is 30. And I'm done. Again, I hope you guys agree with me. The multiplication isn't that hard. It's the cleanup of it. And it's not like that's incredibly difficult, but it's more work. I think it takes more effort to clean it up than it does to multiply it. Any questions on this one? And on the left side? So like you're saying like 2 minus 30?
Yeah.
I can't, because remember yesterday's lesson, in order for me to get a radical and combine it with something else, they have to have like radicals. So if that 30 on the other side had a radical 30 after it, then I could combine it. So it's like having x's and x's on both. Right now they don't have matching radicals. So yeah. So in case you guys didn't hear her question, she was just wondering like, can I combine those and make it like a negative 28 radical 30? Not the way it is, but if it looked like this, whoops, if it looked like 2 radical 30 minus 30 radical 30, then yes, I could right there. Because then I would say they're like radicals, I can put them together. Okay? So, good question. But yeah, that was yesterday's lesson, right? The combining the stuff. All right. So notice, didn't take a lot of steps to do. Let me change this to black. I think I was in red. So, all right. Here is part C. You may not like the way this one looks, and I can understand. Now, I was going to do the problem that had a minus in there, but I'm like, you know what? Now I'm going to let them do that one, right? Normally, I tend to do some of the harder ones, but there's only 2 of these, and the one that I'm going to leave for you guys has a minus in it. So I'll let you guys do that. But this is distribution again, right? But foiling or whatever you want to call it. So I am going to have to distribute 4 different times. Okay? Again, look at all your radicals. Ask yourself if you can simplify anything. So radical 2, nope. Radical 5, nope. The other radical 5 and radical 2 I can't do. So I'm basically stuck here, so I'm going to go ahead and multiply. So just like, let's forget to change this. I hope maybe one day somebody invents like one of these digital ones. You know how they have those ones that have multiple colors, right? It'd be cool if they had a digital one where I could just like press red, green, stuff like that. That'd be pretty cool. Invent it. I'll pay you. So here's the first one. All right. So that's going to be my first multiplication. So I'm going to get, let me put it down here. Radical 2 times radical 2 is radical 4. So notice that'll simplify in a bit. Radical 2 times 3 radical 5, that's positive. 1 times 3 is 3. Radical 2 times radical 5 is radical 10. And now I'm going to do the bottom. Okay? So 5 radical 5 times radical 2, or 5 times 1 is 5, and radical 5 times radical 2 is radical 10. And then the last one, 5 radical 5 times 3 radical 5, so 3 times 5 is 15, radical 25. Notice I do have some like terms right here, okay? 3 radical 10 and 5 radical 10. They're like radicals. So I can combine those into 8 radical 10. And then the radical 4 is going to become a 2. What's going to happen to the radical 25? That's going to become a 5. Okay, there's a lot of things that are going to happen right now. So here you go. Radical 4, that's 2. 3 radical 10 plus 5 radical 10, that's 8 radical 10. Plus, this 25 is going to become a 5. And 5 times 15 is what? I know 4 times 15 is 60, so it's going to be 75. 2 plus 75, that's 77. Plus 8, radical 10. And before I celebrate that I got this thing done, I double check my radical. Radical 10, it's either 1 and 10, which doesn't work. It never works when you use the 1. 2 and 5, they don't have square roots. And that's it. So that's done. Okay? So we are finished with this problem. All right. We're going to move into the back of the homework. And the back of the homework has letters. So we're going to do those. Okay? And I'll ask you after the... So I did 3 without, I'm going to do 3 with. And if you guys are like, yeah, we're good, then I'll stop. If you guys are like, show us another one, okay, fine. We'll do one more. But after that, I'm going to do it more. But I don't want to keep going and just kind of force feeding you guys stuff if you already get it. So this is just numbers. That's what the first part of this was, okay? Any questions on this one? So let's get to this next one that now will have some numbers in it. So this is the first one that I wanted to do for you guys. Let's see, negative square root 3n cubed times negative 4 square root of 15n cubed. We're going to treat it the same exact way, guys, okay? We're going to treat it the same way. The only difference is this. When I was telling you guys in the first 3 examples, look at the square roots, what can you simplify, and we would check to see if any of the numbers work. The easiest thing to do with variables is leave them alone. Don't mess with them. I know that I can reduce square root of n cubed. That's n square root of n. I know that. But I don't want to do that because n square root of n looks so much more complicated than square root of n cubed. That just looks like one letter inside. But then if I simplify it, it becomes 2. I'd rather not do that. I'll do that at the end. The letters I'll take care of at the very end. Okay? But the numbers, if I can simplify, I'll still do those. Okay? But right here, the radical 3 on the first term, I can't do anything with it. And the radical 15, I can't do anything with that either because it's 1 and 15, it's 3 and 5, they don't have square roots, so can't do anything with it. Okay? So it is what it is. This is the way it looks. So let's go ahead and multiply. I have a negative 1 times a negative 4. So that's a positive 4. and then square root of, multiplying the insides, 3 times 15 is 45, and then that's going to be n to the what? 6, right? N to the 6. All right. Now I'm going to start to break stuff down. I need 45 broken down into something with the square root. 9 and 5. Okay. So I'm going to put 9 times 5, because I know that 9 is going to go out. And then n to the 6, that's n squared, n squared, n squared, right? Remember, my index is 2. I'll put a little 2 right there just to remind you guys. And since the index is 2 and it matches these powers, how many n's are going to go outside? Well, n cubed. Yeah, that's what it's going to look like. 3 of them are going out, and it's going to become an n cubed. Okay? Because all 3 of those are going to leave. So n. That's what it's supposed to look like on the outside. So here we go. Let me get this 9 and move it out. When I move out the 9, it becomes a 3. So 4 times 3 is 12. The n's are coming out. That's n cubed. Okay? And I get square root of what's left? Just a 5. Thank you. And there you go. Right? Again, if you're wondering where the heck did that n cubed come from, it's right here. This n came out, this n came out, and this n came out. So that's n. That's n to the 3rd power. See, if we would have simplified the n's first, the left side radical would have said n radical n. The right side radical would have said n radical n. Then when you multiply, then it would have been n squared radical n squared. Then when you take out that other n, it becomes n cubed. It's messy. It's easier just to leave the letters alone, fix them later, okay? And then deal with the numbers first. So, to me personally, if you want to be adventurous and do everything at once, go for it. I mean, I can do it too. I prefer not to because it can confuse you. So if it's easy, do it the easiest way, right? It's not like you're cheating. Nobody wants to do math the hard way, right? Everybody wants to learn shortcuts. Everybody wants to learn the best way. So that's my advice to you. The letters, leave them till later. The numbers, do them whenever you want. Okay? So, all right. Now we're going to do a cubic problem. Okay? We haven't done any cubics. There are a couple. So, cubed root of 20 times the cubed root of 25. So no letters in this one, and I noticed with the cubed roots, there's, where is it at? Yeah, there's a couple that have letters, there's a couple that don't. Okay, so we'll do one right now that does. So after this one does. So let's go ahead and multiply these together. There are no numbers on the outside. Well, there is 1 and 1. So 1 times 1 is 1. We're not going to worry about that. The inside is the cubed root of. By the way, I know I didn't ask, but I should have. I just, in my head, I knew this already. Is there any way for me to break down 20 so that it has a cubed root? So remember, you're only dividing by 1, 8, and then 27. Well, that's too big. 8 doesn't divide any of those, so you can't break them down. Okay? Maybe after, but not right now. 20 times 25, what is that? 0, 10, 500? All right. So, of course, right now you'd want to use your calculator, okay, to figure out what multiply or what divides 500. I'll tell you right now, 125 does it 4 times. 4 times 125 is 500. And I know that 125 has a cubed root. What's the cubed root of 125? Not 25. It's 5. Yeah, it's 5. So it's 5 cubed root of 4. There is no cubed root of 4, so that's done. Okay, we got one more, and then if you guys want to see another one, I can show you one. Okay. Again, I'm not wasting your time because this is homework. You're going to do it anyway, right? But in a sense, you might say like, no, but I can do it faster without you help. But one more, just so we can do at least 6 out of the 16. Any questions on this one? All right, so this next one is kind of like an example of maybe what you would call the toughest cubes that you might see. But, I mean, not entirely the toughest one, but. So here we go. 24 and cube. Because this one actually has the ability to be reduced before I get into it. Okay. Now for the first radical, what can I do to maybe fix it just a little bit? Take out the negative, right? Now the n, it doesn't come out cleanly. N to the fourth would become n cubed root of n. It doesn't disappear completely, so I'm going to leave it. Because cubed root, just to show you, n to the fourth is the same as cubed root of n cubed times n, which would be n cubed root n. To me, that looks more complicated than just n to the fourth. Now, me, I can see it, so I'm like, that might not be the best idea for this one. But would it work for the second one? Yeah, that one I can take it out and just leave it outside and not have to worry about it, right? So in that case, I might do that there, but I might not do it for the first one, okay? And then we'll fix the first one later. But I am going to take out that negative, as you said. Let me do that right here. And again, Adrian, he said take out the n to the fourth. That's not, I said not to do it, not because it's wrong. Okay, you could do it, and it's still right, okay? It's just, I think it might make it a little bit more complicated, so let's try to stay away from complicated. Now, as for the other one, okay, can I break down 24 into something that has a cubed root? What number? Because I can't. It's an 8, right? I can take out an 8, so let me write 8 times 3. And then this n cubed, I'm going to highlight it right now. Oops, I put a 2. I don't know why I did that. But that has a matching index. That means I can take it out too. Right? So that, and I'm going to take it out and it's going to be cleanly removed. So I'm going to go ahead and do that. So negative cubed root of 10n to the fourth times, well, the cube root of 8 is 2. And then there's an n that's going to come out with it. And then the only thing left will be a cube root of 3. Now, I always get people asking, what, do I have to do it? No, you don't. You could have just multiplied negative 10 times 24. But then that's negative 240, and now you're trying to figure out what works for 240. Whereas right now, when I multiply them, what number is going to be inside the radical? 30. That's way better than 240, right? So if you can simplify a little bit, make your life easier, do it. If not, you don't have to. You have a calculator, right? So, but since I don't have one right now, right here, I'm going to try to bring it down as much as possible. So let's multiply the front numbers. Negative 1 times 2n, that's negative 2n cubed root of 30n cubed n. Notice, I know it's n to the fourth, but I'm going to go ahead and break it apart right now. Okay? So I'm going to go ahead and break that apart. So I know that n is going to come out. What about 30? Can I simplify 30 in any way to get a cubed root? Let's see. I got to be able to divide by 1, but that doesn't help. 8 does not go into 30. Next would be 27, but that doesn't fit. And you don't want to try 64. The number's too big. So 30 is stuck. That's the way it's going to be. Okay? So I'm going to only take out this n, and we get negative 2n squared cubed root of 30n. And this would be your final answer.